Chapter 1.4, Fractions and Decimals. So today we're going to be talking about dealing with terminating decimals and repeating decimals. So terminating, to terminate, to end, okay? Any decimal that once you finish the division, it ends. For example, 1.6, 3.257. If when you are finished with your division, there are no more remainders, it's terminating, you're done. You may have a lot of decimals, but as long as it ends at some point, it's considered terminating. Now, if you plug some division into a calculator, however, and you get something like 9.642193875, and it looks like it ends, this obviously does not repeat. There are just a whole bunch of digits, and it does not look like it actually terminates. On a calculator only has so many spaces for digits. So if you get a number that looks like this, you can assume that it is actually not terminating. Okay? Just because the calculator runs out of room doesn't mean that the actual number runs out of room. Okay? All right, so repeating decimal. Numbers like 1/3. So the fraction 1/3 is written like this, but the decimal is 0.33333, and it keeps repeating over and over and over again. We also write it as 0.3 with a line over the 3 because this digit is repeating over and over and over. Okay? It doesn't end, it just repeats over and over. So we call this a repeating decimal. So we're going to be exploring both of these today. So let's jump into example 1. The pull of gravity is weaker on the moon than on Earth. The fraction 4/25 represents the ratio of the moon's gravity to Earth's gravity. Use long division to write this fraction as a decimal. So, long division. The numerator is the dividend. It is the number that goes inside. The denominator is the divisor. It is the number you are dividing by. So for example, we have 4 divided by 25. The 4 goes on the inside. Now 25 doesn't go into 4, so I'm going to add a decimal and add a couple of zeros back here. When you divide, that decimal goes straight up. And now I ignore the decimal and pretend it's not even there. So how many times does 25 go into 40? It goes in once. So the 1 goes above the 0. 1 times 25 is 25. Again, I'm going to ignore the decimal. We're going to subtract. I have 15. Bring down the 0. 25 goes into 156 times. 6 times 25 is 150. I'm left with nothing. I don't have any remainders here. I don't need to add a 0 and bring it down. I am just finished. So 0.16, this is an example of a terminating decimal because I don't have anything else. I have 0. I have 0 left. I don't need to add another 0 and bring it down. I am finished. So let's take a look here at example 2. Let's use long division to write 3/11 as a decimal. Okay, again, the 3, the numerator, that's your dividend. It goes inside your division symbol. The 11, that's your divisor. Well, 11 doesn't go into 3. So again, we'll put a decimal, put a couple zeros back here, bring that decimal straight up into my answer if the computer would cooperate, and now we ignore it. So 11 goes into 30 twice, 2 times 11 is 22. 30 minus 22 is 8. Bring down the 0. 11 goes into 80 7 times. 11 times 7 is 77. 80 minus 77 is 3. Okay, 11 doesn't go into 3, so I need to add another 0. Bring it down. Again, 2. 2 times 11 is 22. 30 minus 22 is 8. Add another 0. Bring it down. 11 goes into 80 7 times. And now I'm starting to see a pattern. I'm starting to see two patterns. First, I'm seeing it in my answer, 2, 7, 2, 7. But I'm also seeing it in my actual problem, 30 minus 22, 80 minus 77. 30 minus 22, 80 minus 77. So this is going to become a repeating. Okay, it's a repeating decimal. We can show that two ways. We can show it by putting, if it will cooperate, dot, dot, dot after it. Okay, or more formally, I can write 0.27 with the repeating line over the 2 and the 7. It goes over both because both the 2 and the 7, the whole 27, repeat over and over and over again. Okay, example 3. Now I have a decimal, 1 and 325 thousandths, and I want it as a mixed number in simplest form. So 1.325 is equal to 1 and 325 over 1,000. I'm going to go ahead and simplify. I'm going to divide the fraction, if I can actually do that correctly. Divide by 25 over 25. Now this 1, this whole number, it comes with it. I'm only dividing the fraction. So I'm left with 1 and 13/40. Now, I knew that 25 was the greatest common factor, the GCF, was 25. If you didn't, you can just look for a common factor. Okay, I know that 5 is a common factor, so you could have divided by 5 and then looked at your new answer. Do they have any common factors? I knew that the greatest common factor was 25, so I was able to simplify in one step. Just make sure that whatever you think your final answer is, that fraction is in simplest form. If it isn't, if they have a common factor, then you need to reduce again until it is in simplest form. Okay? All right, this is a long one today. Example 4, order from least to greatest. So the first thing that I always do when working with problems like these is I always write them vertically. So I have 2, I have 2.55, and I have 2 and 6/18. Now I have a couple of options. The first option I'm going to talk about is actually, in my opinion, a little bit easier when you're only dealing with a few numbers. So least to greatest. Well, I know that 2 by itself is going to be the least. So I'm just going to put it over here. So I'm left with 2.55 and 2 and 6/18. So I'm going to ask myself, is one of these greater than half or greater than 2.5, and is the other less than 2.5? Well, I know 2.5 is 2.5, and 2.55 is greater than 2.5. And I know that half of 18 is 9. Well, 6 is less than 9, so this has to be less than a half. So that tells me that 2 and 6/18 has to be less than 2.55. So order from greatest to least, 2.55, 2 and 6/18, and 2. Now, option 2 is to convert all of these to either decimals or to fractions. So I know 2 6/18, that's the same as 1/3 or 2 1/3. And I know that 2 1/3 is 2.3 repeating. So if I order these, 2.0, 2.55, and 2.33 repeating, well, I can't tell from the 2 because I always compare left to right. So the 2's I can't tell, but I see that the 5 has the greatest number in the tenths place, so it goes first. The 3 is the next greatest, so it goes second, and the 0 is last. It is the smallest. Please, however, be sure to write the original number in your answer. So even if you convert this 2 6/18 into a decimal, that's fine, but I want the original in your answer. Okay? All right, so let's apply that to example 5. For a survey, adults were asked to choose one animal from a list of 4 that they thought was the most endangered species. Of the adults surveyed, 0.25 chose black rhinos, 10/48 chose a tiger, 5/12 chose giant panda, and 0.125 chose a mako shark. List their choices in order of frequency. So, let's kind of break this down a little bit here. We have the black rhino, or we'll just call him the rhino, and he was 0.25. We have the tiger, which was 10/48. We have the panda, which was 5/12. And we have the shark, the mako shark, which was 0.125. So, since 2 of these are already in fraction or in decimals, I'm going to decide to use a calculator in order to turn the others into fraction or into decimals as well. So if I do punch 10 divided by 48 into my calculator, I get 0.2083 with that 3 repeating. Notice that there's a line over it. The panda, I get 0.416 with the 6 repeating. So if I take my numbers and I write them in order from just in order, and line up those decimals. So 0.25, 0.2083, 0.416, and 0.125. So I want them in order of frequency. This is actually going to want it in from greatest to least. Order of frequency, greatest to least. So the greatest is 0.416. If I compare my tenths place, the largest number is a 4, which is the panda. Now my answer is not going to be the decimals in order. It's going to be the name of the animal, or when it says list their choices, their choice is not a decimal. The choice is a rhino, a tiger, a panda, or a shark. So first it was the panda. Then I have my 2's in the tenths place. My hundredths place I have a 5 or a 0. Well, the 5 is bigger. So then we have the rhino. And then after that, the tiger. And we're going to follow that up with the smallest, with the shark. So this is the answer. Now, if you want to turn all of the decimals, the 0.25 and the 0.125, into fractions and then create common denominators to compare your fractions, you can. It seems like a little bit less work to turn those fractions into decimal those and compare those. Okay, a lot of examples today, but that is the end. Go ahead and complete your QCs and CYUs, and I will see you soon.